In this video, we will review how to find the vertex of a quadratic function. In order to determine the vertex, we first have to find the value of a, b, and c. So again, reviewing that, it's really ax squared plus bx plus c. The number in front of x squared is really 1, so a equals 1, b equals -4, and c equals 5. Now to determine the axis of symmetry, or the x-coordinate, we use the formula x equals -b over 2a. So in this case, we get x equals negative times the value of b, which if we look up above, the value of b is -4. So it's negative times -4 all over 2 times the value of a, which is 1. So if I simplify that, this gives us x equals negative times -4 is +4, 2 times 1 is 2, so we get x equals 2. Now, for the y-coordinate of the vertex, we know now that x equals 2, and we have to figure out what y equals, because again, the x-coordinate of the vertex is the x-coordinate of the axis of symmetry. So in order to do this, we have to figure out, if I rewrite my whole equation, we have y equals x squared minus 4x plus 5. So what you have to do is you have to substitute this value of 2 in for x in every part of the equation. So if I were to do that, I would have y equals, and rewrite it wherever there was an x, I'm putting parentheses, and then you're going to fill in the numbers. So my value of x is 2, so I can fill this into both spots. So I fill in a 2 and a 2. And now if I simplify, 2 squared is 4, 4 times 2 is 8, plus 5, which if we keep going, we're going to get y equals 4 minus 8 is -4, plus 5, so y equals 1. So our vertex would be at 2, 1. Now the final calculation we'd have to conduct in order to finish our warm-up is we have to find the y-intercept. So we already said from the previous slide that a was 1, b was -4, and c was 5. So in order to do so, our y-intercept is always at 0, c. So in this case, the value of c is 5, so I'm going to substitute it into my ordered pair. So my y-intercept would be at 0,